So far, we've been learning the fundamentals of the Python programming language. And now, before we move on to how to use Python specifically for scripting within the GIS environment, we're going to cover debugging and error handling. I've never met a programmer that doesn't have to use debugging and error handling. In fact, you should think about it this way. Good programmers are those who know how to utilize debugging and error handling most effectively. Therefore, this is one of the most important topics when learning how to program. There are three main types of errors you will happen upon in Python: syntax, exceptions, and logic errors. As we've discussed before, syntax is text, numbers, and symbols that are entered via an interface for the programming language's compiler or interpreter. And as it turns out, compilers are really picky about how you put things. We're all probably familiar with our grammar police friends who correct us all the time. Well, think of the Python compiler as a stricter version of this. Syntax errors in Python will pop up a dialog box like these. The message in this box says syntax error. There was an error in your program, EOL, while scanning single quoted string. EOL stands for end of line. This error means that there was an open quote somewhere, but the line ended before a closing quote was found. Another type of syntax error will simply say invalid syntax. An invalid syntax error means that there is a line that Python doesn't know what to do with. You may also see indentation errors that say unindent does not match outer indentation level, an unexpected indent. If you get this kind of error, you should check that all your lines of code are properly aligned in the correct columns. You can place your cursor at the start of each line and look at the column indicator at the bottom right of the IDLE to check this. Token errors in Python will pop up in a dialog box like this one. The message in this box states that there's a token error in a multi-line statement. This error usually means that there is an open parentheses somewhere on a line, but not matching closing parentheses. Python reached the end of the file while looking for the closing parentheses. Exceptions, or things we didn't expect, occur during the running of a script. It's worth mentioning that since this occurs during the running of the script, sometimes called runtime errors, then the interpreter must have already successfully compiled the script. Runtime errors occur as your program executes. Since Python is an interpreted language, these errors will not occur until the flow of control in your program reaches the line with the problem. These messages can seem hard to understand at first. The first part tells you which file had the error. In the example here, the file is test.py, and the error occurs on line 7. The next line shows the actual line of code where the error occurred. This line executes the main function. Similarly, the next two lines say that the error occurred on line 5 within main, and that the line with the error is print hello. Lastly, the actual name error says that global name hello is not defined. A name error means that Python tried to use a variable or function name, such as hello, based on a previous definition. If it hasn't been defined at this point, you will get an error. These errors are caused by not matching the correct number of substitutions into a string format. The string format in both cases requires 2 substitutions. The first error is caused by attempting to substitute 3 arguments, and the second error is caused by trying to substitute 1 argument. Semantic or logic errors are problems with the design of your program. These usually do not produce any error message, but instead cause your program to behave incorrectly. These types of errors can be tricky to track down and are often caused by accidentally using one variable in a place where a different variable is intended, or by simply doing some math incorrectly. This example code will execute, but it will not output the total number of apples picked. Instead, it will output the amount that was picked the last time. This simple example is easy to fix, but in a more complicated program, it can be difficult to find such problems. Consider this hypothetical pseudocode for an input process output design pattern program. In the first pseudocode, you cannot be sure that all of the input and processing code is working correctly. All you see is your incorrect output. You can add extra print statements to your code so that you can see the intermediate processing. If you modify your code to work something like the second example, you'll be more easily able to see where the problems are. Once you're sure your program is working correctly, you can comment out the extra print statements. Learning to interpret the error messages is just one way you can help to debug your code. Using extra print statements to display the value of your program's variables is a useful way to figure out what's going on with your program. This example only has one intermediate calculation, but the same concept applies to more complicated programs. The final result is obviously completely wrong because the value today should be less than the future value. To try to find the problem, we can add a number of extra print statements to try to see what's going on within the program. Here we look at the intermediate calculation of PV factor. We know this should be a number smaller than 1, but for some reason it is 9.5238. We now know to focus on this line of code to look for the problem. We can see that the exponent operator is not typed correctly, resulting in an incorrect calculation. The line should be PV factor equals 1 divided by 1 plus r to the n power. Now with the change, we can see that this correction has solved the problem and the calculation is now correct. You may encounter times when you cannot track down an error that is causing your program to fail dramatically. There are a few steps you can take to recover. Avoid errors. Hopefully you will not get to this point. You should try to write only a few lines of code and then execute your program. Write a few more and execute it again. If you encounter a problem, you'll be able to look at the last few things you modified to find the issues. Prepare. You should save your programs every time you begin a new part. If you reach a milestone, make a backup copy. All you have to do is select Save As and name your file with a 2 or a 3. If you're working on file name 7.py and cannot fix something you've broken, you can just go back to file name 6. When you're done, you can copy all of the old files into a subdirectory and rename your final solution as you see fit. You can also attempt to comment out a troublesome section of code to see if that is causing the problem. You can use the Format menu inside IDLE to place the comment character in front of a section of code after highlighting it. Try isolating different sections of code so that you can narrow down the problem. When all else fails, you can start with a new empty file. Then copy and paste in small sections of code, one at a time. Each time you add a section, run your program to see if the newly added section causes the problem.